This is the Earth Science Classroom. Welcome back to the channel. So this video is on soil erosion, and in particular we're looking at the agents of soil erosion. Now this is part of the AP Environmental Science Review Series, Unit 4 on Earth Systems, and looking at each agent and how it all combines to create soil degradation, the loss of fertile topsoil, and the effect it has on agriculture, farming, and the population because of the growing of food through soil. The understanding of soil and soil science and how we use soil to our benefit to produce food in high yields, production, and create a food source for our world population around the world, whether it's based on local, national, or worldwide. But soil and the understanding and appreciation of soil and how soil is regenerated, renewed, how it's formed, its composition, its nutrient capacity, how it holds water, how it holds different roots, and how it can grow different plants and yield crops is vitally important for this course in environmental science. So either before human activity on the earth occurred with agriculture and irrigation between 15 to 10,000 years ago, soil and the topsoil has always been renewed and generated over time, a long time, and also been broken down and had soil erosion occur in locations around the world. And this happens at a certain rate. Now, when you add in the human impact, the agriculture, the change of relief, or the change of land use types, and how we over fertilize, we over produce farms and tillage and different farming techniques to change our landscape for our benefit, to create more food, this has created extra emphasis on understanding how the soil erodes, the speed or rate of erosion, and what we can do to combat this in order to maintain our topsoil, to maintain our crops and our farmlands, to maintain our food production. So as a definition, soil erosion is defined as the removal of the top layer or topsoil in that particular location and transported to another location. And once we have the definition, we can look at the three main parts of soil erosion, which is the detachment of the physical soil particles from the ground, and that will allow the erosional agents to transport those particles that are detached from the surface. And then once transpiration is over and the energy is gone, then there will be deposition in a new location. So in general, soil erosion is the removal of that topsoil. Now this is done through various types. The main two types are water and wind. Now you can include ice in this in terms of the frozen component of water with glaciers and ice caps, but water and wind are the main two agents. So water erosion is one of the principal erosional agents acting upon soil to cause soil erosion. Now, it's the first probably thought you have of erosion of soil is it raining and there be overland flow, surface runoff, and the water's going to mechanically or physically take the soil with it down slope with gravity and transport that sediment away from the farm or the land. So we can discuss the natural precip, the meteoric water, versus the anthropogenic, the farming, the irrigation, the extra water added to the farmland. But the natural sources of water are incredibly powerful as an erosional agent. So the first stage of water erosion on soil is going to be the splash erosion, the raindrop impact falling from the atmosphere, from the cloud, down at its terminal velocity based on mass, and having an impact on the soil and dislodging and breaking up the soil as it hits. So the impact is going to cause dispersion of the soil particles, and then the water is going to do two things. Based on soil texture, soil porosity levels, the water is going to infiltrate and percolate into the soil. Now, if it doesn't, it's going to cause what's called overland flow or surface runoff. It's going to run over the surface of the land, and that is where the majority of the soil erosion by water is going to occur. Now, this is either in small thin sheets called sheet erosion, or it's going to cause and create small little channels in the ground, in the landscape, and these are called rills. Now, this is based on the topography and relief of the ground plus the gradient and slope. Then the larger channels will start to be formed through the excess water flowing downhill. This is called gully erosion. And then you have ephemeral gullies or ephemeral channels being created for a very short time, and this is due to maybe flash flooding or large amounts of fast moving rainfall over the land. But you get these different sized channels moving downstream, downhill, taking this soil with the water as it flows over the land. Then you have wind. Wind is another major erosional agent like water, and this air moving across the surface of the land caused by difference in pressure based on the climate and latitude elevation, and this air motion, this wind, is going to transport the soil particles through various means, either across the ground, which is creep, either bouncing through the air along the ground, which causes abrasion, which is siltation, or just the small particles based on mass are held in suspension and carried with the wind from location to location to the point where it is deposited at a new location due to the energy. Now, this is based on the wind strength, wind direction, prevailing winds, which are seasonal perhaps, or based on wind direction and air masses and climate fluctuations throughout the year or throughout a longer time period. It could even be tectonic, where the winds are created through various uplifts or valley creations or changes in global temperatures. So the wind is going to play a large role in the movement of the sediment and the transportation, and if you have various landscapes or reliefs, that would affect the wind. So anything close to the surface is going to have laminar flow, very smooth flow of air. You go higher up into the atmosphere, you get more of a turbulent boundary layer where you can have more eddies and more turbulent wind moving, which will cause a lot more erosion or potentially more erosion, and to the point where you get high enough where there's no friction into the free atmosphere or the geostrophic winds, where the air is going to move faster but without friction. So when the air comes in contact with the vegetation or the surface or different topographies or reliefs, it's going to cause a lot of friction and slow down the wind and have less energy, therefore less chance of moving material from place to place. So the wind erosion is a lot on the physics of wind and direction and drag versus the different types of forces involved, and vegetation plays a very large part, also does soil texture. Now, based on latitude, elevation, climate, and seasonality, you might get the water component of this location freezing into ice. Now, ice can or is a very effective erosional agent for both rocks and also for soil and farmland. Now, based on location, yes, a lot of the farmlands, especially in America, are not always susceptible to ice erosion or any kind of ice caps or glaciers, and this is an uncommon aspect of soil erosion. But in the AP Environmental Science test, we have to cover all our bases in case questions come up about this. So ice erosion is a erosional agent, and solar fluxion is where you have the mass movement of water in terms of either semi-frozen or fully frozen water underground moving in a freeze-thaw process down with gravity, down with the slope, and this large amount of soil as a large unit moving down the slope very slowly as in terms of creeping, and this is caused by the change in temperatures either daily or seasonal, but the movement of the ground and the soil through the freezing and melting of the water inside the soil based on porosity going downhill, and this can cause a lot of erosion. Now, glacial scour is the actual abrasion, the actual mechanical, physical weight, mass of the ice pushing down on the soil, on the ground, on the crust, and actually breaking down with mechanical weathering the top layer of the soil. And this also is to do with plucking. So plucking can be the removal or picking up of sediment or materials from the topsoil or from the soil and moving it with the glacier as this frozen river moves downhill during times of glacial advance, and also can take up and basically deposit material in terms of glacial retreat when the area gets warmer and the glaciers again move back towards the colder regions. So gravity, mass movement, and mass wasting, all terms that mean the same thing. It means that the relief or topography is not completely flat, and where you have areas of inclination, an area of a hill or a mountain, or any kind of gradient or slope, you're going to have the force of gravity act upon the sediment, act upon the water, act upon any material that's moving down slope, whether it's water, ice, or any kind of wind, and you're going to have this natural force that is going to accelerate and increase the rate of erosion on that surface based on what's acting with it, either water, ice, or wind. So in terms of the steeper the gradient, the higher the erosional rate, the faster the runoff of water, and perhaps even the speed of wind, whether it's protection or it's open to the prevailing winds, the windward side versus leeward side. But you have this very imposing force that's going to influence the soil material and the rate of erosion and the depth of soil and speed of regeneration of soil, and also the amount of vegetation that can grow on that gradient, that slope, that soil. So in terms of soil science, pedology, in terms of the cultivation, agricultural, and farming industry for apes, you're looking at topsoil being the vital component which we want to save. We want to keep this topsoil in place, in situ, as long as possible to maximize our yield of crops, whether it's mono cultivation or poly cultivation with various crops based on seasons or locations. But in terms of irrigation, fertilization, fertilizers application, in terms of pesticides, but you want to keep that topsoil there and not allow it to be removed through erosional processes, as discussed earlier, through different agents. You want to keep this topsoil because it has the majority of organic material. It contains the O and the A horizon, has majority of the root systems, it has a lot of the nutrients, and it forms the basis to build a deep, very thorough soil with master horizons through to the E horizon, the B, and the C down to the R, which is the bedrock. So you want that topsoil to be consistent, thick, with lots of nutrients, potassium and phosphorus and nitrogen, and lots of cations to produce colloids and movement through leaching, with pores and porosity, with infiltration of water to carry down and to hold that water for nutrient exchange and the growth and the health and fertility of the soil for growing biomass, which is obviously vegetation. So the topsoil is very, very important to understand its composition and understand how it is grown and developed in the soil, and also how to stop it being eroded away from the farms. So also to consider, there are certain elements about the landscape that are affecting the rate or speed of soil erosion in that particular location. And these four main components are the vegetation, the climate, the soil texture, and also the slope or relief or topography of that location. Now this obviously can change based on location, but these are the four main components that can affect soil erosion. So vegetation can bind the soil, it can create a thicker soil, a more compact soil in terms of the strength. It can also create a barrier for the winds. It can have the root systems, allow water percolation, exchange of colloids and nutrients, and vegetation is going to be generally a very positive component to have on your land to make sure soil stays where it is. Next is the slope or relief. Now the gradient is going to impact vegetation in terms of the root development. It's going to impact the amount of water that's going to run off and the speed at which the erosion happens. But also, if you have a very steep area, it just makes soil erosion a lot easier to occur compared to a flatter terrain where the water is not going to run off, the wind, and also infiltration rates will increase to allow more vegetation to grow. Then we've got the soil texture. Soil texture is the composition of the soil, whether it is silty, sandy, or clay, and the three main physical or mineral components of the soil, in addition to obviously the organic material and the pore space filled with either water or air. But the composition of the soil is going to create the soil texture, and therefore will have an impact on soil erosion. Now, in terms of the more susceptible soil type or soil texture, the 12 classes to erosion is actually more silt, and more sand or more clay based soil is definitely more resistant. Now there are different variations in terms of the loam and percentages, amount of water holding capacity, but silt is the main type that is more susceptible to erosion, or it's less resistant and will be removed easier than the other types of soil. And then finally we have climate. Now climate is going to tie in and link in to all of these components. In terms of vegetation, the climate is going to have a great impact on vegetation in terms of the precip, in terms of temperature, and how this vegetation is going to grow and develop into a biome or the levels of succession. And obviously the climate is going to dictate the soil texture, whether it's more of a clay soil or sandy soil. Now in terms of the relief and slope, climate can have an impact on that in terms of if it's going to be the windward side or leeward side, and the different climates based on rain shadows, based on where it's going to rain and the elevation. So all of these 4 different aspects of our landscape are all interconnected, all influence each other, and play a major role in the rate of soil erosion at that particular location. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.